Hi guys, sorry I didn't get this out last night, but I'm not exactly feeling too good. Voice about gone. Hopefully it'll be okay by Monday. So let's try to get this done. Today we're jumping to Mod 4 Lesson 22, and in this objective, you're going to be able to compare of a the size of a product based on the size of the factors. So not really solving it, okay? But we're basically using our reasonableness based on the size of the factors to determine the product, okay? Now the standard on this was NF25, and it's known as scaling or resizing. And all we're talking about is what is the product based on the size of the factors, okay? And the factors being the two numbers or fractions that we're multiplying against each other. All right, so let's put this to practice and see how it works. Now, first one, I have 4/4 times 12. So I've got a fraction times a whole number, but my fraction happens to be equal to 1. So that means my product should be equal to the other factor. So let's see if this works out. Here's 4/4 times 1/12, 12 over 1, which gives me 48/4. And 4 goes into 48 12 times. Okay, so it works. So if we have a factor that is equal to 1, then our product will be equal to the other factor. Okay, now let's take a look at another one. This time we have a factor that is less than 1. So since it's less than 1, that means our product should be less than the other factor, because it's actually 3/4 of 12. And let's see this work out. 3/4 times 12, which is 12 over 1, which gives us 3 times 12 over 4 times 1. 4 goes into 4 one time, 4 goes into 12 3 times, and we equal 9 over 1, which gives us 9. And that'd be 9 inches. And we can see 3/4 of 12 is 9 inches. So since we multiply by a fraction less than 1, our product was less than the other factor. Now let's see what happens when we multiply by a fraction that is greater than 1. So this one here happens to be greater than 1. So that means our product should be greater than this factor. Let's try it out. 5 times 4, 5/4 times 12, which means 12 over 1, which equals, and we can see we can't eliminate anything because it's 5. Well, yes, we can. 5 times 12 over 4 times 1. 4 goes into 4 one time, 4 goes into 12 3 times, and we ended up with 15 over 1, which equals 15. So you can see, since we multiplied by a fraction greater than 1, our product was greater than the other factor. All right, let's see what happens when we do this with just all fractions. Okay. Excuse me. Now, once again, here I have a fraction that's equal to 1. So that means my product should be equal to this fraction, 1/3. Let's try it. 4/4 times 1/3, which equals 4 times 1 over 4 times 3. We take out our 4's and we have 1/3 left over. So our product was equal to our other factor. Now we've got a fraction that is less than 1, so that means our product should be less than 1/3. So, because it's saying 3/4 of 1/3. So let's try it out. 3/4 times 1/3, which equals 3 times 1 over 4 times 3. We can cancel out our 3's, and our product is 1/4. And we know 1/4 is less than 1/3. So that reasonableness works out. Our last fraction here is now greater than 1/2 because it's 5/4. So that means that my product should be greater than 1/3. So let's try it. 5/4 times 1/3, which equals, and there's nothing common, so I can multiply it out, which would be 5/12. Now I know that's greater than 1/3, because if I wanted to change 1/3 to 12, I would have to multiply by 4 with 4, and that becomes 4/12. So 1/3 is equal to 4/12. My product was equal to 5/12, which is greater than 1/3. All right, let's try some more. This time we got 1/2 times 5/5. By now we know that's equal to 1. So we got 1/2 times 5/5, which equals 1 times 5 over 2 times 5. Take out our 5's, and we know it's equal to 1/2. So our product is equal to the second factor. Now, once again, we're going with less than 1. So 1/2 times 3/5. That means our product should be less than 3/5. So, and I can see there's nothing common on top and bottom, so I'm just going to multiply it out. 1 times 3 is 3. 2 times 5 is 10. Now, if I wanted to verify that, I know I could take 3/5 and turn it to tenths by multiplying 2 over 2, and that gives me 6/10. Okay, so you can see that my product was less than the other factor, which was 3/5. Now, the last one, we're multiplying by half by a number that is greater than 1. Now, it doesn't matter that it's a second factor because 1/2 times 9/5 is the same as saying 9/5 times 1/2. Okay? Because multiplication, we can do it in any order. Now, when we multiply this out, we know our answer should be greater than 9/5 because we're multiplying greater than 1/2, I mean, because we are multiplying by a fraction greater than 1. So it should be, our answer should be greater than 1/2. So we end up with 9/10. And I can see, I know 1/2 would equal 5/10. So we are definitely greater than 1/2. All right, let's try to apply this to a word problem. It says, at the fair, Valid spends all his money on new books. Pamela spends 2/3 as much as Valid. Ely spends 4/3 as much as Valid. Who spent the most? Okay, so if we think about this, let's take a tape diagram here. And this one here represents what Valid spent. Okay, now Pamela, I know she spent 2/3 as much, so 2/3, and I'm just going to use V for Valid because V will stand for how much Valid spent. So I know V times 2/3 is going to result in 2/3 of V. So I know that this here would be approximately what Pamela. Now I don't need to multiply it to solve that. I just know that she spent 2/3 as much. And since she's multiplying by a fraction that's less than 1, the factor is going to be less than the original amount, which was Valid. Now, the next one says Eli spends 4/3 as much as Valid. Okay, so you're talking about 4/3 times whatever Valid spent. And without even knowing what he spent, I know that that is going to equal greater than V because that 4/3 is greater than 1. So it's actually going to be V's and 1/3 more. And this one here would be Eli. So who spent the most? Eli spent the most, and Pamela, where's my pen? There it is. Pamela spent the least. Okay? Notice we didn't have to work with any numbers. We just used our reasonableness. All right, so the whole thing today is to determine, basically, when we're multiplying a fraction, and let's pick any fraction, doesn't matter, a fraction, and we're going to multiply that times 1, that's going to equal whatever that fraction is. Or for that number, if I take a number and multiply that times 1, it's going to equal whatever number that other factor was. Now, if I take a fraction, that's one of them, Now, if I take a fraction or a number and multiply that by something that is less than 1, that means my product will be less than fraction. And it'll also be less than the number that I multiplied it by, that fraction less than 1. Now, if I take my third possibility and I take a fraction or a number and I multiply that by something that is greater than 1, that means my product will be greater than the original fraction, or it will also be greater than original number that I multiplied it against. Okay? That is known as scaling or resizing. Okay? And it is a big part of the NF 25 standard. See you on Monday.